So 6 point, is it 6? No, 10.1. So this is going to be 10.1, obviously MTS ALG2 10.1 questions 13 through 19. This is going to be 13 through 15 right now. Okay, and so the first three basically work with SOHCAHTOA. SOHCAHTOA is sine, cosine, and tangent. Okay, so get used to these: sine, cosine, and tangent. Okay, so is sine, right? Sine of theta. Remember, theta is the Greek letter for T, and it looks like a circle with a line through it. Okay, and it's pretty easy. Sine is equal to SO, which is opposite, right? So the opposite side, in this case, 2 over the hypotenuse. And remember, the hypotenuse is always the side across from the right angle. Okay? So the longest side is the hypotenuse. So you have 2/6. You can change this to 1/3. Be good. Okay? And then you have sine, so then you want to do cosine. So this should be sine theta, of course, sine theta, and cosine theta is equal to, well, so adjacent over hypotenuse. So you got your adjacent is the line touching, the side that touches the angle of theta. Okay? But also notice that the hypotenuse touches theta. Okay? But the hypotenuse is the hypotenuse. Then there's two legs. There's either the adjacent leg to theta, or there's the opposite leg. So there's either the leg opposite of theta or the leg adjacent or touching it. Right? And they create your perpendicular legs of the right triangle. Okay? So in this case, it's going to be adjacent, which is 4 square roots of 2 over the hypotenuse, in this case, still 6. Now, when you reduce this fraction, you have to remember that you don't take what's inside the radical. What you're reducing is on the outside of the radical. Unless there's radicals. Only radicals can reduce radicals. Does that make sense? So numbers reduce numbers, radicals reduce radicals, letters reduce letters. Okay? So the only thing that goes into 4 and 6 is 2. And it goes in there 2 and 3 times. And so you got 2 square roots of 2 over 3. And that's your final answer. Okay, so that's your reduction. And then they want us to do tangent. Now in tangent, it's going to be tangent of theta. So remember, we have opposite, we have adjacent, we have the hypotenuse. The hypotenuse is always across from the right angle. The opposite's always across from theta, right? So I kind of look at it like this. You got the hypotenuse, you have the opposite, and you have the adjacent, right? And so I'm looking at this guy, and we already know, because we already color-coded him. So it's going to be red over purple, right? The opposite over the adjacent. So in this case, I'm going to have 2 over 4 square roots of 2. And I would get rid of the square root of 2 first, before I break down the fraction, because you're going to end up having to break it down again a lot of times. Okay, so how you get rid of that square root, remember, we got to make it the square root of 2 over the square root of 2. And what that does is it gives us 2 square roots of 2 on the top. And then what is the square root of 2 times the square root of 2? Right? Once you have a pair, you can take one out, right? So it's just 2. 2 times 4 is 8. And now I can reduce it. Now I would reduce it to what goes into both of those, 1 and 4. So you basically just say 2 goes into 2, 2 goes into 8, 1 and 4 times. You don't really need the 1, so you have square root of 2 over 4. And that is your tangent. Okay? Make sure this thing is recording. It is. Alright. So now we can do 14 and 15. 14. Again, it's easiest for me if I just set up. If I just set up the what's adjacent, what's opposite, right? So I look right away and I go, okay, well, I know that this is the hypotenuse, because that's opposite of the right angle. If I'm talking about theta, then the opposite side is right here. So that's O, which leaves 3 to be A. Okay? Once I know that, it's SOHCAHTOA. Right? I can go as easy as sine theta is equal to so opposite 6 square roots of 2 over h, which is 9. Okay? Then I can break it down. 3. So that'd be 2 square roots of 2 over 3. Done. Done, son. Then cosine theta is equal to A over H. That'd be 3 over 9. In this case, 3, so 1/3. And then let's do tangent right here. So give us room over there. So tangent theta is equal to O over A. So 6 square roots of 2 over 3. And then looks like 3 goes into there. 2 square roots of 2 times. All day. So pretty simple. Straightforward. The hardest part to this math is figuring out what's opposite, what's adjacent, right? So again, opposite is across from the theta. Okay, so we got opposite. That leaves this to be adjacent. And of course, hypotenuse is across from the right angle. So again, we have sine theta, cosine theta, tangent theta, right? And then so O over H, square root of 41, A over H, 4 over 41, and tangent is O over stays. This one I got to get rid of. The square root. So I got 4 square roots of 41 all over 41. 41's prime, so I don't worry about reducing. That's your answer. And then, again, we got to do the same thing to this guy. 41 over 41. Oops. Okay, which gives us 5 square roots of 41 over 41. Again, the 41's prime, so we don't reduce it, it's done. And that's SOHCAHTOA.